I will begin this presentation by introducing the background to our research, and my colleagues will take over then to discuss the research activities. This research responds to several challenges for archives in this digital era. Firstly, how can archives remain relevant and not in a backwater in fast-moving political and social moments, especially as so much digital information and processing power is already available readily to the end user? In particular, how can archives ensure that knowledge latent in their digital collections can be made available not just at some later point to scholars, but also is available for use more quickly after it's created in contemporary policy debates and decision-making? Secondly, how can archives, many of which are still working in a predominantly manual paradigm, process very large-scale heterogeneous digital collections and do so quickly? Thirdly, how can archives respond to critical scholarly trends and political movements that are demanding that archives undertake deeper description that can surface hidden trends, narratives, and even unjust consequences? Finally, it remains difficult to find appropriate and available real-world digital archival testbeds upon which to experiment with automated methods for addressing these issues. Social media such as Twitter provide fertile and non-confidential opportunities to create such test collections and pioneer or adapt techniques that potentially can subsequently be implemented with other archived digital collections. Social media have been selectively archived as documentation relevant to societal trends and national contributions by state libraries and academic special collections for almost 2 decades. And also as records generated by key figures, as we're well aware of in the US over the last 4 years, by government archives. Computational techniques developed in digital humanities may offer fertile approaches for archival processing activities, especially appraisal and description. The study we're reporting on today is part of a larger project that is working on several fronts relevant to archival administration. These are detailed in our paper, so I won't go into them here. This study sought to develop proof of concept of automatic methods adapted from digital humanities that could be used to enrich as well as speed up the description and potentially appraisal of archived social media collections. Using a test collection of almost 3.5 million unique English language tweets relevant to COVID-19, China, and Chinese people, it sought to identify instances of hate speech, as well as hard to pinpoint trends in anti-Chinese racist sentiment. It also sought to identify ways to limit algorithmic bias and increase transparency in archival processing.
Here, let me introduce the workflow of the TSMS mapping. The mapping maps a tweet from the set of non-controversial tweets to a tweet from the set of controversial tweets. Mapping could be divided into 3 steps: the hashtag mapping, the TF-IDF similarity calculation, and the emotion similarity calculation. Basically, the requirement of this mapping only consists of the set of non-controversial tweets M and the set of controversial tweets N. Our overall goal could be presented mathematically in the following way. We are trying to construct a mapping T between 2 sets, and the mapping is ideally 1-to-1. The mapping is subject to 2 conditions. For the 2 corresponding tweets from set M and N, they should be close enough in 2 aspects: hashtags and emotion, which could be represented by the function above. The first requirement ensures that the 2 tweets are close in topic, in case they are similar in emotion but describing different aspects. The second requirement ensures that the 2 tweets have similar emotion tendency. Now let's look into 3 steps in detail. The first mapping step is the hashtag mapping. It starts from a non-controversial tweet and maps into multiple tweets that contain the same hashtags. It could be visualized in the figure at the right. The mathematical form of the mapping is to the left. We use two matrices, H1 and H2, to represent the hashtag matrices. And the index ij stands for the jth hashtag is contained in tweet I. Then the selection of tweets with the same hashtags could be represented as H2 H1 transpose. In order to avoid two common hashtags causing overly complex mapping, we eliminate a few most common hashtags. The second mapping is the TF-IDF mapping. It is a selection within the controversial tweets that have the common hashtags with the non-controversial tweets. Here, if we regard the hashtag of each tweet as a document, then the hashtags of all tweets will combine to a group of documents. Then we could calculate the TF-IDF score of each common hashtag. And for each tweet, we could add up the TF-IDF scores of the common hashtags from the pair of tweets MN and get the hashtag relevance between them. Then we could refine our peak of tweets, because as some of the controversial tweets may have the common hashtags, then it is possible for a few tweets to have the same hashtag relevance. The third mapping step is the emotion similarity mapping. This mapping simply calculates the similarity of the emotion vectors of non-controversial tweet M and the candidate controversial tweet N. The metric could vary, such as Euclidean distance, Boston distance, and so on. Then from the candidate tweets, we pick the one that has the highest similarity score. Since the emotion similarity score is based on continuous metrics, it is rare that two controversial tweets may have the same similarity score. Therefore, we could assume that combining three steps, we could get the unique mapping from a non-controversial tweet N star to a controversial tweet N star.
So after developing the TSMS method, we apply it to the CHSTA archive we collected between January and April 2020. As you can see in the table on the left, in the CHSTA archive, there are more than 3 million tweets, and we describe it in the ACES paper, as you can see on the right. And we successfully identified 0.6% of them to be hate speech at the very beginning. Using the TSMS mapping method, we successfully broadened our controversial speech and kind of better understand and identify them in the archive. So both the paper and the archive are publicly available through the links on the right. In this next table, we further present a specific change of the detection rate of controversial speech. By using the TSMS method, we increased detection rate from 0.6% to 6.1%. And if we zoom in to the over 200,000 tweets that are identified on controversial speech, we can see its distribution based on the mapping similarities. In this figure, we use the third quartile range as the cutoff points to identify the over 200,000 hate speech. This result shows that the successful mapping helps us discover that among all the tweets, if they contain similar topics, they likely have emotional similarities. It is feasible to detect whether two tweets contain similar context. As a conclusion, from the perspective of archiving and processing Twitter archives, there are 3 advantages by using the TSMS mapping method. First, the model is flexible, as the TSMS method chooses alternative measurements in the intermediate steps while keeping the body structure to obtain the best performance. Second, it uses one-hot vectorized mapping in which each instance of a non-controversial speech can be mapped to a unique instance of controversial speech. Finally, the TSMS mapping uses a sparse mapping matrix, which provides an easily storing and quickly manipulating archiving process. As an initial exploration in our serious research in CAS, there are a few limitations in the TSMS mapping approach. Because of the complexity in social media archives, there is always a trade-off between the speed of processing and accuracy of labeling categories. In particular, the similarity cutoff is intuitive and set as the third quartile range, while a case-to-case adjustment is always needed. If you are interested in this project of archiving and analyzing COVID-19 on Twitter, you can also refer to the preprint in this link. We also believe that both our approach and the research agenda are applicable to other born digital archives, especially the social media archives and the hate speech archives. Finally, I would like to thank you for watching our presentation. Please let us know if you have any questions.